Okay, section 14.3 on page 200 deals with negative scale factors. Now, this is question 1, it's grade A. This section's all grade A anyway. I've now got to enlarge the shape there, it's a triangle clearly, using centre 5, 5. There's 5, 5, the coordinate there, that's the centre of enlargement. And look, if I draw construction lines through each vertex through the centre of enlargement, now I need to be as accurate as possible, otherwise I will not get helpful construction lines. It's really, really hard to judge it working like, oh, start again, not very good. There, I think, still not very good. Start again. There. Okay, I'm just hoping I've got some accuracy here. So I'll move it just a little bit, makes all the, alright, so let's leave it there. Now, I know it's going to be enlarged by a scale factor of -3. Now, what happens is, if you can visualize it, if I enlarge the shape in this direction, as shown there, using these 3 rays or construction lines, you can see it's going to flip over on itself and become inverted, but still be 3 times as big. So I'm looking for a shape that's going to have a base of 9 and a height of 3. 3 3s are 9, 3 1s are 3. So I need to try and construct that using my guidelines. Now, I think, obviously, if I had a ruler and I could do this in front of you, that would be really good, but I haven't got one. Now, I can see that if I go from here to here, allowing for my inaccuracies, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. Well, that corresponds to the -3 scale factor enlargement of the base 1, 2, 3 squares there. Now, as you can see, from this point here, I go 1 up. Therefore, I can use my guidelines to go 3 down. 1 times 3 is 3, and therefore we have an enlargement of times -3. Then I just join the remaining vertices, you know, corner to corner, and that's it. Alright, the maths adds up. Let's go over it one more time. Base of 3, base of 9 units. Height of 1, height of 1 unit. And I don't care about that one because I just join the ends and I complete my triangle. So look, what have we got? We have an inverted shape that's been enlarged by a scale factor of 3. This is in fact an enlargement of -3. That's grade A. A lot easier to do on paper than it is on the screen. Trust me on this one. I tried doing it before and I completely messed it up. But just appreciate what happens when you enlarge by -3. Now, if this was the centre enlargement and we're coming across this way, like so, through these vertices, through these corners, in this direction, in this general area, excuse me, then we'll be enlarging by a positive scale factor of 3 or 2 or whatever it says. But here, look, it's like we're sort of flipping back on ourselves and enlarging in a negative direction. And so naturally the shape will flip. It appears like it's rotated as well as enlarged, but don't mix the two up. Just the impression that you get, it looks like it's spun around that way, clockwise, by about, oh, let's have a look, 180 degrees and enlarged itself. That's not the case. It's an enlargement by a negative scale factor of 3, or in other words, scale factor -3, and the centre is 5, 5. And that's how they look, alright? And that's all I want to say about that one. Let's just try this one. This is question 2. I took the liberty again preparing the axes earlier. So draw the rectangle 1, 1, 1, etc. 4, 1, 4, 3. It's all there anyway. Enlarge the rectangle with centre 0, 2. Now 0, 2, just put it in, shall we? Is right there. There's 0, 2. I've got to enlarge it and with a scale factor of -2. So usual trick. I'm going to need to get me some vertices. So that one passes straight through that, and that one passes straight through that. I'm not sure where it's going to end up. That will pass straight through that, and that will pass straight through that. So there we go. As you can see, I'm going back on myself through the centre of enlargement. I want to go -2. Now hopefully it won't be too difficult to try and convince you. Let's go back to the pen facility now. So what have I got here? Bam, bam. I think if I look at that distance there, multiplied by 2, I've got that there. So that's that one sorted. So this point is the image of the point 1, 1 when I enlarge it through scale factor -3 and centre 0, 2. That's that one. By the same token, I believe that one should be, it's a little bit inaccurate. I couldn't get it very accurate at all. So if that is 2 units tall, this is going to be 1, 2, 3, 4. It should really, really be there. Okay, and then what we got, so 1, 2, 3 units across, that's the base of the rectangle. So if you double up, 1, 2, 3, 4, 5, 6, there we go. So that's quite accurate, isn't it? And what else should we do? And this one, if we're going 4 units down, 1, 2, 3, 4, that's near enough on the line. And there we go, there's the rectangle that's been enlarged. Let's try and go maybe yellow on that so it stands out, I think. See what happens. So I'm happy with that point and that point. Mathematically it makes sense, even though my construction lines are far from perfect. This runs along the x-axis in the negative direction, and that's a vertical line joining that vertex, that vertex. So I'm happy with the result. I'm not that happy with this construction line there. So I'm going to ignore it. I've done my enlargement of -2. As you can see, a base of 3 units becomes a base of 6 units from -8 to -2. That's a range of 6 units. A height of 2 units becomes a height of 4. So it's definitely twice as big, but in the negative scale factor direction. Alright, so that's how it would look. Now it says enlarge the original rectangle with centre 1 -2. This could be very tricky, but let's have a go anyway. So 1 -2. 1 -2 is right there. I've got to enlarge this shape using that centre of enlargement, and it has to be -1 1/3. Oh, that's absolutely incredible. Lovely. I've now got to try and walk through each corner, pass through this, and come down here somewhere. Right. Now, maybe I need another grid. If I'm making a complete mess of it, we'll have to start again. Let's go for different colour construction lines then, shall we? So you go through that one there and stop complaining. And you go through... If I can get 2 of them right, that might really help, mightn't it? Right, so if I can flip this, that'll be really helpful. Let's take a look. -1 1/3. So 1, 2, 3 units. 1 1/3 times 3 is what? It's 4, isn't it? So 1, 2, 3 becomes 1, 2, 3, 4. So right there, I'm going to put a little cross in red. So 1, 2, 3, 4. So this corresponds to that vertex there. So 1, 2, 3, 1, 2, 3, 4. And this one is how many units away? Well, it doesn't really matter. I know it's 2 units tall from that vertex to that vertex, and if I'm going to go times 1 1/3, 1 1/3 of 2 is going to be, let's just work it out, shall we? So 1 1/3 times 2 is going to be 2 2/3, isn't it? So 2 2/3. So I want to go 2 2/3 down from that position. 2, that's 3. So it's quite hard to judge. 1, 2, 3, 2/3 will be approximately there. So that's that point. That's that point. Now it should follow, therefore, if I join this vertex to that point just there, that vertex, I've got my rectangle. So let's just draw it in. This is how it's going to look. So I can join that to that. Am I happy with that? Well, I've got a base of 3. If I multiply 3 times 1 1/2, just do the calculation. So 1 1/3 times 3. Well, 1 times 3 is 3. 1/3 times 3 is 1. That gives me 4, doesn't it? And look, I've got 1, 2, 3, 4 units across. So I know that's correct. Just carry on doing some joining. From there to there is your 1 2/3 that I calculated earlier. And I can just carry on doing it, can't I? Go straight across 4 units. So that's easy to do. I can do that legitimately because I know by calculation I've got 4 units at the base as well as the top, and then just join the remaining 2 vertices. Now if I've done it perfectly accurately, if I pass this vertex straight away through this centre of enlargement, it should pass through the vertex there. So we'll try it just for fun. If it looks a complete mess, forgive me. You know, I'm just having a go here. So here I go. Start with that vertex, pass through the centre of enlargement, and there you go. It's not bad, is it? So that vertex passing through, well, the construction line passing through anyway, hits the image point right there. It's exactly where it should be. So I'm very happy with that accuracy. I hope you found these little calculations here slightly helpful. They were supposed to be helpful anyway. in terms of, you know, doing a bit of maths to sort out what's going on. And look, it's flipped back on itself in the usual way. It's gone bigger. It's a lot more harder to do -1 1/3 than -2. Obviously, you've got to do a little bit of maths if you're not sure. But that's that one. I think I better pause because it's going to get a little bit long, and that's enough for grade A starter questions. So that forms the first part of 14.3.